to another episode of Math and Silly Hats. Today we're going to be using tables to compare ratios. Unfortunately, this is an intimidating topic and I don't have step-by-step procedures for you to solve every one of these problems, but I can do a few examples as well as offer some general tips for how to complete these. The first is to pay attention to your units. Units both will give you a clue as to how to answer each question, as well as give you an idea of what that answer represents. The next tip, which is tied in, is to consider what the comparisons mean. So, if we have 20 minutes per mile, means it took that person 20 minutes to run a mile, or to drive a mile. Hopefully not to drive a mile. Is a slower speed than 10 minutes per mile. So, this is counterintuitive because 20 is greater than 10, but if we think about what it means to take 20 minutes to travel 1 mile, well, in an hour, the person going at 20 minutes per mile, well, it takes you 20 minutes to go every mile, would only get 3 miles completed in an hour, whereas the person going 10 minutes per mile would go 6 miles in an hour. So this person's actually going faster despite the number 20 being larger than the number 10. A lot of times students will get through most of these problems, but if your final answer is incorrect in terms of interpreting what those units mean, ALEKS will mark that answer as wrong. Let's do an example here using those tips. So we have a comparison of laps over time that each of these 3 runners ran. So Rita ran 24 laps in 4 minutes. Nicole ran 56 laps in 7 minutes. And Ashley ran 25 laps in 5 minutes. So we're asked to do 2 things. First, to find the number of laps per minute run by each of these 3 runners. Our first tip was to pay attention to units. So number of laps per minute. Well, we have a bunch of numbers up here. I can certainly see for Rita, I'm going to be using these 2. But the question comes down to, well, what do I divide by what? Well, we know we have to have laps per minute. So if we have laps per, in other words, divided by minutes, we know we're going to be finding the laps here, 24, and dividing that by the minutes here, 4. So let's go ahead and calculate that. The number of laps that Rita ran was, laps by Rita was 24. So 24 laps in, divided by 4 minutes. The number of minutes ran by Rita, minutes ran by Rita was 4. We can simplify this. 24 divided by 4, there's a 4 present. If you factor both of these, 24 divided by 4 is 6 laps per minute. Next, we'll be looking at Nicole. Again, we want to know the laps per minute run, so we'll be looking at Nicole as the column this time. So Nicole ran how many laps? Nicole ran 56 laps per divided by the number of minutes Nicole ran, the number of minutes it took Nicole to run 56 laps. Nicole, minutes was 7. 56 divided by 7, both of those have a common factor of 7. 56 divided by 7 is 8 laps per minute. It's important that I include these units because I'm going to need that later to make sure that when I compare these two, I know what that unit lets us know. Are they running a number of laps each minute, or are they taking a certain number of minutes to run each lap? So retaining these units is key here. Finally, Ashley. We want to know how many laps Ashley went. So Ashley went how many laps? Ashley went 25 laps in how many minutes? Divided by how many minutes? Minutes for Ashley was 5. Again, we are given nice numbers here because both 25 and 5 have a factor of 5. 25 divided by 5 is 5 laps per minute. So the final question is, who drove fastest? So we're not running here, we're driving, which I guess makes sense because that's a lot of laps per minute. So in 1 minute, Rita went 6 laps, Nicole went 8 laps, and Ashley went 5 laps. So this one is a more straightforward, we want the highest number of laps because that's fastest per minute. So here, Nicole drove the fastest, as she has the highest number of laps per minute. If it was minutes per lap, we would want fewer minutes it took to go each lap. So Ashley would have been the fastest if this unit was backwards, minutes per lap. So be careful and pay attention to your units. It's going to be a clue as to how your answer works out. Let's do one more example. In this example, we're looking at 3 different cameras and how many pictures they were able to take in a certain time period. So we're asked to calculate the number of pictures per second of each of these cameras. So the number of pictures per divided by seconds. So to find each of these, we're going to be looking at the camera and dividing the number of pictures it took by the amount of seconds it took to take those pictures. So this will be a measure of pictures per second. It's going to be uniform units for all of these, pictures per second, so I'm going to go ahead and set that up all now. So for the first camera, we're trying to find the number of pictures the first camera took. So the first camera took 28 pictures. 28 pictures over the course of, first camera took 4 seconds. Now you'll notice my numerator and denominator here, 28 over 4, are not the order in which they appear in the table. We have to be careful to make sure we pay attention to our units. We're trying to find pictures per second. The number of pictures is our second row, so we're dividing this number by our number of seconds, our first row. It's not always going to be top to bottom or bottom to top. We have to pay attention to our units. So 4 divides 28 evenly. 4 goes into 28 7 times, so 7 pictures per second. Our second camera, pictures was 25. And to take those, the second camera took 5 seconds. So now we're going to calculate 25 over 5. Again, those divide evenly into 5 pictures per second. And finally, the third camera, number of pictures, was 63. So 63 pictures over the number of seconds taken by the third camera. Seconds, third camera was 7. Again, these nicely divide. 63 divided by 7 will be 9 pictures per second. Finally, it asks us which camera took pictures fastest. So we want to find the camera that took the most pictures per second. In other words, the fastest camera. So the greatest number of pictures per second was the third camera. Now again, we have to be careful with our units, as if these units were inverted. Say we're using a camera from the 17th century, and it took multiple seconds to take one picture. Well, the one that took the fewest seconds would actually be the fastest. Only 5 seconds per picture. So again, pay attention to your units and think about what these comparisons mean. Be wary of your time and your distance or your number of objects in that time and which order they're in. If you pay attention to your units and make sure you divide properly as well as represent your answers in terms of those units, you should have an easier time answering the comparison question. I hope that this was helpful and that you're all able to complete this topic on your own. Have a great day, everybody. Bye-bye!